So congestion, here the definition for congestion is too many sources sending too much of data too fast for a network to handle. So this is one of the parameter. Another parameter is flow control, that is your data, how it is flowing, incoming and outgoing, that is also cause your congestion. Here you have two types of congestion. One category is lost packet, another category is long delay. What is meant by lost packet? Is nothing but the buffer, what already I have informed about the buffer will be present in your router. If it is overflow, automatically the packets will be lost. Next, for the long delay, if the buffer is not able to handle the packets, if the delay has occurred, obviously there also you have your cost of data. Next slide. So this is a scenario how your queue will be present at the nodes. So here this is your queue shape structure. So here this is the queue maintained for your subscriber, this is for other nodes, then this is for incoming, this is a buffer what we have space. So input buffer, what is meant by input buffer? How much of packets the buffer can handle in the router. Simultaneously, parallelly, the output buffer also should be equally spaced. If there is any delay, what happens? Obviously, the congestion will be occurs. Next slide. So these are the causes of congestion. So first one, if the congestion has happened, these are the parameters which will be handling as difficult constraints. So queuing delay, packet loss, slow network, blocking of new connection, last one is low throughput. So all these parameters will be the defects, major criteria if the congestion has been occurred. Okay, next we are going to see the cause of how the congestion has been occurred. So first point, we are going to see that if you are using your bandwidth very excessively, that is the consumption in the place of 10 subscribers, we are using 15 subscribers, obviously the bandwidth will be very excessively you are using a maximum utilization. So what happens? The buffer could not able to handle your data packets, obviously the congestion will occur. Next criteria is poor subnet management. If it is related with excessive bandwidth. If you are going to give more number of subnets, what happens? There also the delay will occur, obviously the congestion happens. Next one, broadcast storm, multicasting, broader gateway protocol, too many devices you are going to connect to your network, outdated hardware, oversubscription. So these are some of the parameters to be monitored to avoid your congestion. Next. So next, congestion control. So congestion control is classified into two types. One is open loop, another one is closed loop. So in open loop you have 5 policies, in closed loop you have 4 things. What is your open loop? Open loop is nothing but it is prevent, that is before happening your congestion you want to prevent it, that can be controlled by open loop method. For closed loop method is nothing but after congestion happen you are going to avoid your future congestion to be happen. So open loop means previously before congestion you are going to avoid it. This is closed loop after congestion we are going to try to avoid your future things. So what are the policies? In open loop you have 5 policies: retransmission policy, window policy, acknowledgement policy, discarding policy, admission policy. So what is retransmission policy? So whenever congestion happens means your data packets will be lost. So that to be retraced. So for that we are going for retransmission. Next you come for the window policy. This is nothing but your contention window. So what is meant by contention window? I am going to set a window size as 3 for example. So based on that window size, if the window size exceeds your input buffer, obviously what happens? The data packets will be lost. To avoid that, I am going to follow the window policy. Next is acknowledgement policy. Whenever the data receives your acknowledgement, then only the next data to be transmitted. So that is one of the acknowledgement policy. Fourth policy is discarding policy. That is too many of data packets you are going to get it at the receiver means obviously what happens? The buffer will be filling. To avoid that, I am going for discarding policy. Last one is admission policy. So based on the contention size, I am going to have this admission policy. So open loop congestion control is nothing but which will help the congestion before it's happening. Now we comes for your closed loop. Here you have 4 types: backpressure, choke packet, implicit signaling, explicit signaling. Next slide. So these are your effects of congestion, no control. So normal graph, the graph is drawn between your load as well as your throughput. So initially we are going to classify of congestion. So without congestion, no congestion, how will be your graph? After congestion, that is if initially startage of your congestion, what will be your, and severe congestion, what will be your graph? So initially the load and the throughput will be normally in a linear form. Once they started your congestion, it will be delayed somewhat, difference will be present, that is degradation of your throughput will be there. Once the severe congestion happens, what happens? Here it will be degrade totally, it will be degrades your throughput. This is your congestion technology. Now comes your back pressure method. This is your similar thing. One of the method to control your congestion control. Here you have two methods they have given, back pressure and choke packet, implicit and explicit. So first we are going to see, okay, just I will see the overview of this all four methods. So what is back pressure? Is nothing but which will give intimation of congestion. For example, if any of your node, consider third node has been occurred your congestion means, here what happens, that node 3 will send the information to the source by second node, third node, second node, first node as well as the source. Backward it will be sending the information that the congestion has been happened. This is for back pressure. Then if you go for your choke packages, it will not deal with the intermediate nodes. Directly it will be informing that the congestion has been happened in that node to the source itself. So this is comes for your choke packet. Next is explicit and implicit. Next. So just now I have given the overall overview of your back pressure. Here this is your source, that is your destination. I am going to have 4 number of packets, 4 number of nodes. Here this is the data flow graph. For example, here the congestion has been occurred in the third node. So what happened? A back pressure, that is you are going to send the information via node 2, node 1, then to the source, indicating that the congestion has been occurred. This is your back pressure method. Next. This is your choke, the same example, source and destination having 4 nodes. The same node, third node has occurred congestion. Here the difference is it's not intimating the congestion for node 1 and node 2. Directly it is intimating to your source itself. That is known as congestion, that is choke packet, without knowing that the node 2 does not know the congestion has been occurred. Node 1 also does not know. Only the where the congestion has happened, that node as well as the source will be knowing the congestion has happened for the category of choke. Next, implicit congestion signal. Here, by assumption itself, the source will understand the congestion has been occurred. Why? Because if you are going to transmit a packet, what happens? It will be waiting for an acknowledgement. But if the acknowledgement is lost, if it is not get means, automatically it guesses the source that the congestion has been occurred. So that is known as implicit congestion control. Next, explicit congestion control. In explicit congestion control is nothing but the congestion happened that will be intimated either to your source or destination. Either it can be intimated to the source or destination. That is called as explicit. In explicit, you have 2 types of methods. One is forward, another one is backward. That is nothing but the same thing what we have seen in your back pressure. It will be sending a forward direction means, that is, for example, packet 3. Previous slide. Previous slide. Previous slide. See here, this is same example I am going to take it. Here what happened? Same example, packet 3, the congestion has been happened. So here what happened? Here the congestion has been happened. If it is giving the information to the destination, that is in a forward direction, it is called as forward signaling. Then if it is goes for the reverse direction, intimating to the source, then it is called as reverse signaling. So this is comes under your explicit. Next. Next comes your TCP congestion control. So TCP congestion control is nothing but here we are going to have each source determines how much capacity available, that is based on the channel capacity you can make the data flow. That is your congestion control. To avoid your congestion control, you should know the calculation of how much capacity the data can be handled by the channel. By the same way, that amount will be matched with your sender as well as the receiver. This is the help for your TCP congestion control. Next. So this is one of the graphical method to explain. So here the graphical method, your x-axis is round trip time. Round trip time is nothing but the data to and fro, that is transmission as well as the reception. The time duration taken for the data to transmit from source to destination and the acknowledgement from destination to the source. The whole total time period is called as round trip time. And congestion window, how much? For example, I am going to transmit a bulk amount of data. I can't able to transmit as it is. So I am going to set a congestion window. So based on the congestion window size as well as the round trip time, the graph is drawn to find out your congestion control. So initially there is no drawback, no delay or no packet loss. So obviously it will be having a slow start. So you will be setting a threshold, that is indication of congestion. For that I am going to set a threshold. So if I exceed the threshold, what happens? The congestion starts. So what we will be doing, try to avoid the congestion. But what happens? We will be able to try it, but obviously we won't get it. The congestion has been occurred. Then again it reaches. So obviously what happened? Then the performance will be degrades, then starts. So it is going on, starting and increasing and decreasing. This is your TCP congestion control diagram, graphical representation. Next. Next. Ma'am, forward, 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 forward. So now comes your slow start method. So slow start method is nothing but linear additive increase takes too long to ramp up your new TCP connection from the cold start. Initially, how we are going to start your process? You want to have a coordination between your transmitter and the receiver. So what you will be doing, you will be checking. Initially, you will be checking the connection. Establishing connection, you will be checking. So it is a cold start. And based on that, you will be setting your congestion window. The congestion window should matches with your transmitter as a receiver. If it does not matches, the congestion starts. So to avoid that, you are going to do this one. Next. So what I am going to do, I am going to start your source with the congestion window of size 1. Next, I am going to wait for the acknowledgement. After getting acknowledgement, what I will be doing, I will be incrementing my congestion window. So it will become 2. Based on that, you will be setting a timer also. That timer is based on your round trip time. So if the timer exceeds, obviously it will be coming for your retransmission. That is, the packet has been lost, so it will be coming for your retransmission. So these are the 2 situations. We are going to have your slow start. So at the very beginning, that is starting connection, you have your slow start. Next. Okay. Before slide, ma'am. Before slide. So this is your initial slow start method. So what happened? My congestion window has set me 1. Then the packet has been transmitted from your source to receiver, that is sender to the receiver. It is waiting for an acknowledgement. After getting a waiting, then the second packet has been transmitted. It's normally a smooth process, it's going. So here what happened? The congestion size is initially as well. Then it is incremented by 1 plus 1, it will become 2. Next 2 power 2, it will become 4. It's going on increasing in phase. So this is your normal slow start method. Next. Next. Next, ma'am. So here what happened, if you are going on increasing my congestion window, obviously the congestion will be reached because it will be crossing your threshold limit. So the threshold is denoted as SST threshold. Okay. Next. See here what happens, initial behavior, what is this? Initially you have starts, you have your time period, you have your K3, that is your delay level. So based on that, the graph is slowly starting. So initially it starts and maintains. Then it starts decreasing because due to congestion. So randomly you are going to monitor the slow start congestion method. Next. Okay, next comes your fast retransmit and fast recovery. When this fast retransmit and fast recovery occurs, whenever your TCP timeouts, that is if the timer exceeds, then I'll be coming for your fast retransmit. For example, I am setting a timer of round trip time. So if the timer exceeds, means obviously what happened, the acknowledgement has not reached your sender. Obviously the timer will expire. So obviously it will be sending your retransmission. So that is one of the case. So fast retransmit use acknowledgement of, here see example, I am transmitting packet 1, I am getting the acknowledgement, then packet 2, then getting acknowledgement. While transmitting of packet 3, what happens here? It will be dropped in the transmission itself, but it will be waiting for your acknowledgement. So what happened, the source will be understand that some delay has happened, some problem has happened, again it starts retransmitting. It waits for round trip time to closes. After the timer has closes, obviously it will be retransmits the same packet 3. Next one. Next is fast retransmit. Here what happens, if you are going on doing like this, your congestion will start because you are going on increasing your thing. So obviously what I am going to do is I am going to cut down that. I am going to cut down with your half of your thing. So that is based on this your fast retransmit. The window size will become 4. Instead of 4, I am going to set my window size as 2. Next. See here, packet loss here based on 3 duplicate acknowledgement. So what you are going to mean it? For example, I am going to get the acknowledgement of packet 2, then I am started transmitting the packet 3. But here, the acknowledgement of packet 3, instead of sending packet 3 acknowledgement, it will be transmitting the same acknowledgement of what the last packet has been received. So acknowledgement 2, acknowledgement 2, acknowledgement 2. So simultaneously 3 acknowledgements of same packet you are receiving. You understood that the packet has been lost. So you will be going for your retransmission of packet 3. That is fast retransmit. Next ma'am. Fast recovery. What is meant by fast recovery is nothing but the same. The duplication. After the duplication of 3 acknowledgements, you recover that the packet has been lost. Suddenly you will be sending your lost packet because I am transmitting order in the order of packet 1, packet 2, packet 3, packet 4, packet 5. So in between the packet 3 has not get the acknowledgement. I will be waiting for a period of time. Continuously I am getting the same thing. So what happened? The delay has been occurred. To avoid that, I am going to start my retransmission. Next. Modify slow start. This is the thing. If I am going on increasing my contention window, what happened? The congestion will occur. To avoid that, whenever the congestion occurs, I am going to half of my congestion window. That method is called as additive increase, multiplicative decrease. Here comes additive increase, multiplicative decrease. So how I am going to say that? Here is the contention window will be a variable. Here the maximum window size will be minimum of contention window and advertised window. We will be having a comparison between your contention window and the advertisement window. Based on that, for example, my contention window size is 3. My contention window size, advertisement window size is 2. So I will be taking the minimum value instead of 3. So I am going to take the advertised window as 2. Then effective window size is maximum window size minus last byte sent by last byte acknowledged. For example, I am sending a packet number 2. I am getting a packet acknowledgement of packet 2. So I will be taking that by, then subtraction I will be getting the effective window. So this is the calculation. Next. See here, I am going to send it. Packet number 1 from sender to the receiver, I am getting the acknowledgement. Packet number 2, so simultaneously I am getting it. So what happened? Initially I am going to add 1 by 1. Previous in slow start method, it has increased in the terms of 2 power n. For additive method, I am going to increase 1 by 1 only. So initially starts with 1, then 2, then 3, then 4. If going on increasing, this is the method for additive increase. Next ma'am. Next ma'am. Next. This is your multiple decrease. Next. Next ma'am. So here C happens, what happens? So this is your slow start method. This is congestion avoidance technique. Initially it has been started. So you are going to check the 3 things. First thing is you are going to check whether your contention window has been exceed your threshold level or not. Once if it is exceeded, what happened? The congestion starts. So what we will be doing? You will be getting a negative 3 acknowledgement is again fed back it. So this congestion, obviously what happens, I want to cut down the half of thing. Initial diagram we have transmitted 4 packets. So once the congestion starts means what I will be doing, I will be reducing the packet size, contention window size as 2. That is multiplicative decrease. So again I will be starting from 2, then it will become 3, then it will become 4, then 5, then 6. Again the congestion starts means what happens, again it goes for your half of your window size. I am setting your threshold a half of your window size. So that is the thing, concept. Next one. See here, initially my threshold is set as 16. So I am starting my slow start process. Okay, once the threshold has reached, so what happened? My additive increase starts. One by one I will be increasing. After increasing, the congestion starts. Then what I will be doing? I will be reducing my contention window. So my threshold will be set as 10. So slow starts. Then again, additive increase. So what you will be doing? Once you will be increasing your level as well as when the congestion has occurred, you will be decreasing. So the decreasing is called as multiple decreasing. Next. So this is the example how your graph will be growing. Next. So once the threshold has happened, what happened? You will be going for your fast recovery and fast retransmit. Next. So these are your methods to avoid the congestion. So you have some methods, round centric method and horse centric method. So today's topic, what we have seen is congestion control. In the congestion control, so what is meant by congestion, how to avoid it, what are the methods to control, what are the algorithms we have seen. Thank you.